नमस्कार माझ्या मराठी मित्रांनो. वेलकम टू मराठी YouTube channel. And today we are going to see the last topic of the preparation of the data for the machine learning algorithm. So what we have covered till now, let's revise in a minute and then we'll directly jump to this. And after that, in next session, we will see how to use this data to train the algorithm, then evaluate the algorithm, fine tune the algorithm so that it is ready for the productionization. So let's jump to this. Yeah, so as of now, in a just minute, so that who has watching this video first time, they also come to know that what we have covered till now. So guys, we have covered till now data cleaning. Basically we clean the data wherever we have find the missing value. Okay, we just dealt with that missing value in a different way. Okay, so please watch previous video. I have covered in detailed description about this. नंतर आपण बघितलं होतं हाऊ टू हँडलिंग द टेक्स्ट अँड द कॅटेगरिकल ॲट्रिब्यूट्स, राईट. सो ॲज वी नो दॅट मशीन learning algorithm only deal with the numerical data, so it is very important if we have any text data or if we have any categorical data that needs to be converted into the numerical. Then after that we have jumped to the fourth point, that is feature scaling. So basically feature scaling means that we must have the data in constant scale, right? Otherwise it will not do the prediction properly and it may have the arise a issue of a biases. Okay, as it treat the higher value very well and the lower value not. So just to avoid our whole data in one scale, we use two different method called as a min max scalar, and second is the standardization. And if I remember, this was my previous video, I have explained what is the difference between the min max and the standard scalar. So please go and watch it before jump to this before watching this video. And today the last topic we are going to see the custom transformer and the transformation pipeline. And once this is done, we are ready for the training. So rather, so to not waste the much time, let's jump to the Jupyter notebook where I'll explain this what is a custom transformer and what is the transformation pipeline. So yeah, 1 second, let me clear the screen. uh, okay, now let's jump to the, I hope jump to the custom transformer. So today we are going to see the custom trans. So basically what happened guys, when we are working with the uh, machine learning algorithm, okay, existing feature most of the time is not giving any value addition when we are wanted to do the prediction, right? So most of the time we require to add a new features, okay, in our algorithms, or we have to, how we can add these new features by analyzing the data. And when we talk to the SMEs, okay, we understood that we have to do some kind of we have to add some new features, something this is also called as a feature engineering. So basically for that I'm going to use a Sklearn classes called as base estimator and the transformer mixin. So what exactly does that? This transformer mixin, it is a class where from where we are going to inherit the fit and the transform method. So to now what now before that let me just explain you what are the columns or what are the attributes we have. So I have the housing data frame. So in housing data frame, if you see, we have the column called as a longitude, latitude, and then housing median, total rooms, total bedrooms, population, household, median income, and the ocean proximity. So after consultation I understood that there are the new feature we can derive from that, and the feature name called as a rooms per bedroom. Rooms per bedroom. There is other feature we can derive from it which will help us for the prediction called as a population per household. The third feature I can derive from his, that is bedrooms. Okay, bedrooms per room. Yeah. So this is something called as a rooms per bedroom. So second is the population per households, and third is the bedrooms per room. So this is these features I can derive from it is just a simple mathematical calculations. Okay, that is divide the total number of rooms divide by total bedrooms, it will give the rooms per bedroom. So basically I do that room dividation of bedroom, it will give me the rooms per bedroom. Similarly for population, I'll do population divide by household, it will give me the population per household. And then bedrooms per room divide by room, it will give me the bedrooms per room. But if we do this manually, by single line of code, then when we have the new data, or if we want to do any something kind of calculation on new data, definitely this new data doesn't contain these features, guys. Okay, let me take the pen. It doesn't contain these features. Okay, so every time you have to, before passing this data to the training, every time we have to execute this line of code and then transform the data for the training. So it's better to create the class of fit and transform, which we have used for the standardization while calculation, when we are dealing with the null values. So it's always good to use the fit and transform method to do this. Okay, now we confuse like how I can use a fit and transform method if I want to do this custom transformation. Okay, this is called as a custom transformation. Now sklearn come for us and it gives the class called as a transformer mixin. Okay, so we can inherit the property of fit and transform from this class, and we can do this customization, so where we only call that class and use that. Okay, let me explain how we can do that. So before that, I know that I want to rooms per bedroom, and if I know the rooms per bedroom, the number that rooms contain, if I want to convert this into the matrix, then basically this is okay, this is 0, this is 1, this is 2, this is 3, right? Again, this is 0, 1, 2, 3. So if I want to rooms, then this is a column number 3, this is column number 4, this is column number 5. So whatever features I have to get, I need to assign some numbers to them. So to assign two numbers to them, for that what I will say, I create the number that room underscore ix, bedroom, population and household, and assign the number 3456, which has that number. Okay. After that, I will create the class called as a class custom attributes. Okay. And in the class custom attributes, I will initialize the method called as the do the initialization of the class. So it's basically, what does it mean that add bedrooms per room? So if I want to calculate this feature, I'll mark this as a true. Otherwise, if I do not want this feature, okay, bedrooms per room, I'll make this as a false. This is just for the showcase. Otherwise, you can avoid this as well and directly jump into the fit and transform method. So in the fit, I do not want to do anything. Okay, so I'll make the fit method as it is. Okay, so I do not do, so I keep as a nulls, and in the transform method, I will add those mathematical information here. Once again, yeah. So what happens in the def transform? Okay, what I'm doing, if you can focus guys here, in fit I'm not going to do. So I inherit this property from where, which class guys? Transformer mixin class. Okay, so what I'm doing here, I'm just doing this mathematical matrix calculation. So here I'm giving the rooms per, okay, let me use the pen. Okay, so in the rooms per household, I'm just passing all my, so column dot dot, as we know, the all the rows and the room ix column divided by the all the rows and the household column. So I'm basically dividing the all value from my room column and from household column. So this is something called as a numpy this is something called as a matrix division we are doing here. Okay, we are achieving this similarly for the population per household, and in this way we are getting these new features. Now if we mark this as a add bedrooms per room as a true, then this will feature will we are going to calculate. But if this is false, then this new feature we are not going to calculate. And what we are returning, guys, we are returning the x, that is the value. Okay, that means this numby dot c underscore, it will actually do the concatenation. So whatever, we already have the x value, right? Okay, so x value is nothing my the x value is nothing my housing matrices. I'm doing just concatenation of new feature with my existing feature. This is what called as a np.c underscore, and this way I'm able to derive the new formula, new features, and concatenate with my existing data. Let me run this so that I can show you. Correct. Okay, before that, so we have housing head. Now here we are getting housing. Let me run this. Housing values, let me show you what housing values I have. Okay, so housing value, it will just convert my data frame into the numerical matrix, and it contains all my data from rooms, bedrooms, and all, and even categorical as well. Okay, now what I have to do, guys, I have to just call that class. So for that I will, yeah, so this way I'm making address room per room false, so that it will not calculate that value. However, it will calculate this value, rooms per bedroom and the population per household only, as I mark this feature as a false. I do not want right now. And after that, I am passing housing dot values here. So it will pass this matrix to my attribute address, and it will give me this. So now if you look at this housing extra attributes like this, okay, you can see the new matrices is, see, if you want to see only the first 5 rows, then you just use slicing here, 5 first 5 row, 1 second, and all the columns. Okay, so it will only show the first 5 rows of the data. So this is what called as the custom transformer, guys. This is something called as a custom transformation. Now I hope you understand. So what is the benefit of using this custom transformer, guys? If you can use, you have to write only once. Okay, and whenever you have the new data, you just use this class to add the new feature into the existing feature. Otherwise you train it on this, but when you try to train this thing on the new data may not contain this feature. So it is always good practice to use this class before passing new data for the train and testing. Now the next point is called as a transformation pipeline. So transformation pipeline, basically whatever we have did till now, like, okay, whatever we did till now, like uh, data cleaning plus uh, what else, feature scaling, then for the categorization we did the one hot encoder or feature transformation for that sake. Okay, we need to combine whole this into one pipeline. So we want to execute this thing one after another. So this is what we call as a pipeline. Whenever we pass the new data, now we have the data in housing, which is a raw data, right? Okay, so if I want to execute this action one after another, okay, this is called as a pipeline. Then I have to create the pipeline, right? One way to create the pipeline using simple in Pythonic way, but it's better to use the Sklearn Pipeline class, okay, which will give us this ability to work to do it faster rather than we start from scratch. Okay, so let me showcase how we can do it. Okay, so for that, guys, we need to import some Sklearn Pipeline class. Okay, then we are going to import the standard scalar. Last time I only explained as I explained in my previous video, I explained only the theoretical part of what is the difference between standard scalar and the min max scalar. But here we can do it with the very one line of code using the accessing the class of standard scalar from Sklearn pre-processing. Now how you can create the pipeline? This is the important. So it's very simple line of code, guys. You just, now this is a num pipeline. Why it is num pipeline? Means numerical pipeline. There are two different pipelines we have to create. We cannot apply the same thing for the categorical. So what I did here, we use the numerical pipeline, okay, and in the numerical pipeline we want these steps to be executed sequentially. So first we will deal with the imputation. So in the imputation we calculate the median value, okay, and we'll replace that null value with the median value. So we have to give the name as an imputer. Second, we did the combine attributes adder. Okay, so here we are doing the combine. By default value is false for that, this one, uh, bedrooms. Okay, yeah, add per bedroom. So this will also calculate it as it is. Okay, and next is the standard scaler. So we have to scale our data. So we just need to mention what method you want to apply on the numerical in this pipeline tuple. So pipeline is actually tuple. Okay, it's a sorry, so pipeline is a function and it contains the list of tuple. Okay, so we have to pass as a list of tuple into this pipeline object. Okay, and it will do the our work very sequentially. Now once we created object of num pipeline, we have to pass the data, right? And now to pass the data, okay, I'll call that object num pipeline and call the method called as fit transform. So fit basically do this fitting and transform the data. So I have to do this on my housing numerical data. So I'll just execute it, and then once it is done, this way we have our transform data. So let me show you here how it look like. This is again a data frame. One second, it's a numpy array. I'm sorry. Yeah, so this way we have the housing num transform data. So it will contain all my numerical data along with my uh, it contains all numerical data to be transformed. Now you can observe all the data is also scale, scale into the value. Previously we have the, if you can look at this data, we have the something population 2237 2 point 2015, and this median is 29, total bedrooms is 3873, but all has been scaled down something between 0 to 1. Right now my all data is into scale down. It happens because of the standard scaler. Even it added the new attributes from the combine attributes adder. Even it will replace my null value with the median value. Understood? Now this is about the numerical data, but how I can deal with the categorical data means, I cannot create the another pipeline for the categorical. Yeah, we can, but we want that numerical pipeline and the categorical pipeline must happen in once. I do not want to be happen in twice. Okay, so for that the Sklearn provide the class called as a column transformer. Okay, so column transformer basically uh, it basically combine your numerical transformation and the categorical transformation all together, and it will give the full pipeline. Okay, so how we can do, let me, so this way we use the column transformer class. Okay, and after that now we have the, okay, so first of all what we have to do, we have to take the list of housing numerical data into numerical attributes. Then we know that we have only one text categorical column called as a ocean proximity. So I will save that ocean proximity as a okay, as a list into the categorical attributes, and then I have to initialize the full transformation pipeline. So I'll create the object of full pipeline, and in that I am passing again, it is a list of tuple. So in that the num pipeline num attributes, so the num pipeline is what I already created before. Okay, so I call that num pipeline, and I'm passing the value of into the num pipeline called as a num attributes. So it will do this all this step all together. Okay, and in categorical I use one hot encoder method. So basically I use categorical attributes for that one hot encoder. So I already explained what is the difference between one hot encoding, label encoding. If you miss it, please go and watch it. Okay, that will be very helpful. So this way I will use my numerical pipeline to convert the numerical attributes into the proper format, and the one hot encoder. And after that I just need to pass my whole data to the full pipeline, fit, transform, and housing. So housing contains my all data basically. Here I haven't done anything extra, I just pass this housing data. So suppose, just imagine if you get the new data, right? If you get the new data, then you just need to use this pipeline method, pass that data. It will convert your numerical data into the numerical, using numerical pipeline, using proper format, and the categorical data in the categorical format. But make sure that it contains same architect, same schema what housing column has. It will not work for the any other data if it has a different schema than housing. Okay, so we just need to execute it, and done. This way we have now housing prepare data. So you can see now it is again the new, it contains the array of all the information. Okay, so I hope so till this time you guys understand what we have covered. We have covered this custom transformation and the, okay, we have covered the custom transformation and transformation pipeline. So please use this in your projects as well. It is very helpful and it makes something some good standard. In, as I said last time, I will explain how I can use now this data to train the model. Once I have the train model, how I can evaluate my model, and if once evaluation done, how I can do the fine tuning of that model. So I hope so we will see you later. Thank you guys till that time. Keep watching. Thank you. Bye bye.